So last time we talked about the slope of a tangent to a curve. And we ended up creating this little formula here, which I call the difference quotient. And that's commonly what you'll hear people call it in the mathematical community. Whoops. This thing right here is the difference quotient. And if you remember, we talked about a step 1 and a step 2 for a process for finding the instantaneous rate of change. So that's step 1 and step 2 is this point right here. So first you simplify the expression and then you set h to 0. And that will give you the formula, or sorry, the expression for what the instantaneous rate of change is. And if it's in general, it could be in terms of x, or it could be just a number if you're given the value of x. So that two-step process is a little bit annoying because who wants to write step 1 and step 2 when you could just have a single formula? So instead of having this step 1 and step 2 process, we have this beautiful formula right here, which is the centerpiece of what you understand in calculus. This is the key formula that really underlines high school calculus. Now, of course, I say high school, but we will cover post-secondary material too, not in this course, but in the next course in January. But anyway, we have to continue here and develop this formula before we can get that far. So I'd like to now talk about how you would use this formula to do an example that really is very similar to what we did last time. So let's take a look at example 30. I am going to go really, really slow with these questions because it's important that we go through these in a very calm way because they are a little bit scary for people the first time they see it. Notice that the word derivative is used here. So some people in the chat last week were asking me, hey, what's derivative? What does that mean? So derivative, it is the same thing as slope of a tangent geometrically. So derivative is slope of tangent. So what we're going to do now is find the slope of a tangent for this function here, f of x equals x squared, but not just at a value of x like x equals 3 or x equals 4, at any value of x. You might be like, well, how does that relate to last week? So I'm going to just dig up one of our notes from last week, and let's see if I can put something more relevant to what you remember from last time. So let me just find the solution to that lesson that we had last week. So it's basically the last question we did, or the second last question we did. This one right here. So that was our lesson from last week. Let's take a look here. We said estimate the slope of the tangent, and then forget about the estimate. We talked about getting the exact slope. So we simplified that difference quotient and set h to 0. So you see the working parts here. We see this f of x plus h minus f of x over h, which is exactly what you have here. And then instead of saying step 1 and step 2 with set h to 0 as a second step, you can combine them together into a single limit expression right here. So that's what we're doing. The next thing is, in this question, we use the value of x equals 3, but in general, we can use any value of x and then plug in the value of x later. Finally, we can talk about the symbol here, f prime of x. So f prime of x just means slope of tangent or derivative. So let me know in the chat, who's seen this before? Who's seen this kind of stuff before? Anybody else seen this before? Okay. So basically, we're looking at the vast majority of people that are learning this for the first time. And I'm just going to tell you that it is a little bit scary to do the examples we're about to do right now. But I promise you that it's only going to be a couple of examples that we do this way, and then after that, all the answers that we get, there are shortcuts. So what will take us right now, it'll take us pretty much 10 minutes to do this question, and then later, once you learn the shortcuts, later meaning later today, you can do this question in less than 10 seconds. So that's what we're going to play. We're going to play it out like that. So let's take a look at using this formula to do this question. Now, I'll keep this thing here, but it's from last time, so I'm just going to kind of put it on the side here. And I've noticed I didn't copy the actual question, so let me just dig up the question as well. So I promise I will revisit what we just said there once we complete the question. So here we go. So sharpen your pencil here because we're going to write a bunch of limits for the next 10 minutes or less. So we can go equals. And we'll have a limit here. And it's h goes to 0. Because ultimately, we're setting h to 0, so the limit will involve h. And in this case, f of x plus h refers to this function here, f of x. So there's your function x squared. And in the first bracket, we're finding f of x plus h, which in this case, f of x is equal to this x squared, so we replace the x squared with x plus h. And on this side over here, we have f of x, which literally you just put the x there. So if you're looking at it side by side with what we did last time, you notice that it's pretty much the same thing here, but look here, look at where I'm highlighting the mouse. Here I have 3 plus h instead of x plus h, all squared. And the reason I have 3 here is because in the example that we had last time, we were specifically interested in x equals 3. So because we only cared about x equals 3, we didn't really concern ourselves with finding a general expression. But in this case, we are going to keep x as general as possible. So how do we simplify that? Well, you have your algebra skills, I think. The quadratics material you were very good at. So here, just want to expand the heck out of that and see what happens. So if we take a look at this first bracketed quantity squared, we just copy it twice. And slowly but surely, we're going to simplify this just like last time. Our goal is to get rid of the h on the bottom. Just like last time, this step here with the happy face where I cross out the h's, we're trying to get rid of that h on the bottom. So we can expand this out using the distributive rule for binomials. So we can have your x squared plus xh plus xh plus h squared. And we're always looking for something to cancel. I noticed that the x squareds cancel. We can cross those right out. And that leaves us with 2xh minus plus h squared. Okay, let me pause there and just ask you in the chat here, are there any questions? Would you like some clarification about anything up to this point? It's very quiet today. Just keep in mind we're doing what we did at the end of last class. We're just putting a limit in the front. Thank you, Mohammed. We're just putting a limit in the front, and we are keeping x as x in general. We're not putting a number for x. So what do we do next? Well, our goal is to get rid of that h on the bottom. So on the top here, you notice that they have an h in common. Yes. Well, yeah, we are going to cancel them out, Victorio. We're going to cancel them out, but we're going to factor it first. You need to factor it before you cancel, okay? So now we have very close to what we need for the answer, because these h's cancel. We put that in brackets. And there you have it. The h's cancel. And now, if you compare to what we did last time, we've achieved this thing here. We've simplified the difference quotient as much as possible. And now we're going to set h to 0, which is what this limit allows us to do. If you remember from last time, some people ask, why don't you just set h to 0 right away? Just do it here. Just set h to 0. If you try to set h to 0 early, you're going to get 0 over 0. And you're going to keep on getting 0 over 0 all day until you get here. Now you're not going to get 0 over 0. Now you can actually plug in h equals 0 and get an answer, which this answer would equal 2x plus 0 or 2x. So what we've just calculated here is the instantaneous rate of change. So we can say that the instantaneous rate of change, and there you have it. The instantaneous rate of change is equal to 2x. So this symbol here, where I say this thing here, you pronounce it f prime of x. So that symbol there, that quotation mark, we say prime. Also, this equals 2x. Now, how does it relate to the example on the right here? Well, what we have in here is a very beautiful formula that we could then use to find the slope of the tangent anywhere on the parabola f of x equals x squared, not just x equals 3. So let's take a look here. What is the value when you put 3 in for x? What is the value when you put 3 in for x? What do you get here? 2 times 3, right? Which is 6. You see it? We get the same answer as last time, except now we have this elegant formula. So what we just did took basically half a page of writing to go from here to this sweet little formula which tells us how to find the instantaneous rate of change. This arrow here took us half a page of writing, but later today I will give you shortcuts on how you can go from here to here in less than 10 seconds. And then we'll practice those shortcuts for the remaining amount of lesson today. So when I first learned this stuff as a student, so that is the formula for IROC. Yes, it is. So this thing here has many names, and I'll say all of the names for it. The one name is IROC, or instantaneous rate of change, which is what Vittorio said. Very good. We can also say slope of tangent. Now, don't mind my lack of grammar skills. I'm trying to say it like with keywords. Slope of tangent or slope of the tangent. And ultimately, the big one, the one that we're going to use a lot in this course and in general in calculus, derivative. Yeah, Shaquille, it's basically the same as last time, except we don't put x equals 3. We leave x as general as possible. Thank you. So the word here is derivative. Derivative. Trying to spell it with my very slow working stylus today. There we go. This is the word that you need to really hone in on, but I'll just highlight these as well. So when I say to you find the derivative, or when someone says to you find the derivative, they're talking about instantaneous rate of change. They're talking about slope of a tangent. Okay, well, anyway, that is a marathon of a question. And I don't want you to get too stressed out about it. The worst case scenario is on a test. I might ask you to do this long process here one time. And how do you know that I would ask you to do it this long and painful way? Well, there's a very key phrase here, and I'll just highlight it. So to do it the long way, it's called first principles. So if someone asks you, or if you're reading a reference and it says we calculate or derive it by first principles, that's what we're talking about here. First principles means start with this formula here, this very foundational formula in calculus, and get yourself to the formula for the instantaneous rate of change, or in other words, the derivative. So for the rest of today's class, I'm going to try as much as possible to use the word derivative instead of using these ones. Not because the other ones are wrong, they're equally valid, but because I need you to get used to the word derivative. So derivative is a noun, but you can also use it as a verb. You can say differentiate. So this process here, going through this arrow here, the word is differentiate. So let me just write that word here, differentiate. It's kind of funny, I'm spelling it vertically, differentiate. And the process is called differentiation, or some people will say derive. I'm not too concerned about these verbs. I just want you to be able to understand the word derivative. So if I say the word differentiate, I'm just asking you in a question, we're really just saying find the derivative. And if you need clarification, you can always ask me in the chat, no problem. So that was the example that we did last time and how it connects to the new notation for today. We're going to repeat this process a couple more times. The one time is going to be just another polynomial, just like the one we did. And then the one after that is going to be a more complicated one. And it's going to probably scare a few people because of the algebra, but it's really just the process that I want you to focus on. So from here to here, just keep in mind, in the back of your mind there, that there is a shortcut that I'm going to teach you. And for those that have taken calculus, you really know how easy the shortcut is. And I promise that even if you haven't seen this before, you're going to find the shortcut really easy. So let's go through this process again one more time for this example. And then we can proceed to do another tougher example. And then after that, we'll deal with the shortcut. So here we go. Just going to set up my little text here. So the formula goes, now your tests are open book, so you don't have to memorize this formula. But I remember as a calculus student back in the day that I had to memorize one of these versions. There's different ways to write it, but this is the way that I usually see it or like to present it. So anyway, let's go through this process again for this more complicated function. So this time the function is this quadratic, yet in this case it has two terms. So we're going to get a little bit messier here. But if you remember what I did with you last time, I put brackets like that and color-coded. Yes, someone asked me if the tests are open book. Well, I have no real way to prevent it, so I don't mind if you have your notes with you. It's just that if you're writing the test and your book's open, it slows you down, so you still have to know your stuff. So it's kind of like a trade-off between using your time effectively and knowing the stuff well enough that you don't have to look at the book at all. Okay. The process here is pretty much what we're going to do now is plug in x and x plus h. So in this case, we have x plus h here and x plus h. And then over here we have x and we have x. So as you can see here, we're going to have a little bit of a headache expanding and simplifying this, but nothing too dangerous, hopefully. So let's take a look here and how you would expand that first square bracket out. So the first thing I'm going to do is copy this one down twice. And then some other stuff we could do here is, well, we don't really need those brackets. So perhaps I should just not write them at all. So let's expand that out here. So this one becomes minus 2x squared plus 5x. And over here, we can expand the first bracket out. I'll just deal with this first here. So here we go on the next step. Lots of fun algebra time. So let's expand these brackets out. We actually can copy and paste what we have from the previous question there, because it's x plus h times x plus h. Or you can just write it again. It's short enough that you can get away with that. At this point, I don't think you need the square brackets. So what I might do is just bring this back here and get rid of the square brackets. So we have here 2x squared, 4xh, and 2h squared. Okay. Help me out here. What can we simplify? After you expand all of that out, what is available to simplify? Like terms. Thank you, Prabhiti. So this one here is going to be like with that, and we have a like term here. So that's gone. And then at the end of it, I think that's it. I think that's all you can really do here. So let's just write it down one more time without the extra terms there. So we would have here 4x8, whoops, like that. And at this point, what would we do next? Yep, factor the h out. And there you have it. We're basically one step away from finishing this question. In this case, the h's cancel, which was the big issue. Let's cancel those h's out. And now nothing interferes with us letting h equal 0. Because now we can evaluate the limit immediately. We can plug in h equals 0 here, and it's all good. So we end up with 4x plus 2 times 0 minus 5, which is 4x minus 5. That's the answer. Let's summarize it over here. So we can say here that when f of x equals 2x squared minus 5x, the instantaneous rate of change, or the derivative, is 4x minus 5. So, I mean, you're going to start to question, like, is there a shortcut? Or you're starting to see similar numbers in the actual answer. Like, for example, I see a 5 here, and I see a 5 there. I see an x here, then the x went away. Here there was x squared, and then became x. So there's certain patterns that you're going to start to, that are going to emerge. But once I reveal the formula to you, it's actually really easy. So let's do one more question that's a bit more involved. And I remember giving you an example to try on your own for homework, which was, I believe, question number 29. And then I said we would review 29, the general version, later. So we're basically going to do the generalized version of question 29 now. Are there any questions about this process? Please let me know. So I will continue then, I guess. I don't see any other questions. We'll go with question 32. And 32 is just a longer version of algebra, so I'm just going to recycle this thing here. I'm just going to recycle the formula quickly. And the question here, as you can see, says first principles. So with first principles, we're still just using that starting point. And that's pretty much the process. Probably the most annoying thing is going to be you writing the word limit all the time. But it's just something you get used to. A lot of students get irritated by writing the word limit, but anyway, it is part of a process that you're learning. In this case, the function is the reciprocal function. It's f of x equals 1 over x. So what we're going to do now is take the reciprocal of that numerator. So we'll have here 1 over x plus h. That represents f of x plus h. And then we're going to take f of x, which is literally just the original function. So we get that. Simplifying this is not something that we've really explored too much this semester, although we have seen rational expressions on occasion in the quadratics unit. So at this point here, I like to do a little mathematical, not a trick, but a pattern. So instead of writing this thing like that, I'm going to do the following. I'm going to put 1 over h outside and then put square brackets and write it like that. Mathematically, these are equivalent. It's just that the second way that I'm writing it avoids the need for a fraction inside of a fraction. So when you have fraction in a fraction, it's a little bit annoying because we get like what's called nested fractions, and they tend to mess people up in terms of organizing their algebra. So that's what you can do always, even with questions like the earlier ones. You can put the h on the outside and put 1 over h. Now it's a matter of taking this and turning it into a single fraction. For example, if you dig back in your memory to grade 11, we're going to try to find a common denominator for this rational expression. So what I'll do is I'll multiply the first one by x over x. And let me just put a dot there. Oops. Yes, it's a reciprocal. The function is. I'm not sure how that relates to the step here, though, but yes. Praviti, please explain. I'm not really sure what you're referring to. It is this. It is the reciprocal function, but what in addition to?
I just wanted to ask about, so 1 over h, taking it out of the entire fraction itself, because it's a division, would it not be h over 1, or am I?
Oh, okay. I got you. Okay. So yeah, I understand Praviti's question perfectly now. So let me go over here. I'm gonna just take this thing here and do something on the side. Ready? If you have a over b, which is what the top is, let's just say, and then you divide it by c, then this is equal to a over b. I'm going to do it like old school, like grade 4. I'm going to do divide by c, and then you invert and multiply a over b, and then you would invert and multiply and be 1 over c. Okay? Let me replace the c with h and make this a really, really big fraction like that. And then it's exactly the structure that you see in the question. Does that help? Do you get it down? Yes, perfect. You're very welcome. So to clarify for those that were kind of like not sure about the question, Praviti and I were discussing this. Is it 1 over h or is it h over 1? And I was just trying to justify why it is 1 over h in the front. So thank you for that question. It's a good question. So let's get back to business here. The main story, which is to clean up this disaster. So let's clean up this disaster here, okay? Lots of h's. So over here, let me just erase that and fresh slate, clean slate. On the bottom here, we're going to have x plus h. So now we have a common denominator. And on the top of the first fraction, we'll have x, which is this guy over here. Let me highlight that in red or something. So that's this guy over here. And then this guy over here is going to go right there. See if we can copy and paste a little bit here. There we go. So now we have a common denominator, and now we should be on our way to figuring out the rest of the question. Remember, your goal is always to cancel out this h. This h on the bottom here, you need to get rid of it. And even though it's sticking out in the front here, we still need to get rid of it. So with this fraction and this fraction as a difference, I can write them as a single fraction and just subtract the numerators like that. And I think at this point you start to see what's going to unfold. So we can take out the negative sign here. That's x minus h. I think I'll switch to the black font again. We don't need any distractions there. Okay. So we get negative h. Any thoughts on cancellation? Can we cancel out those h's now? What are your thoughts there? Actually, you can, which is shocking. But let me do it on the next step here so that I can clarify it better. Whoops. So what you can do here, let's just space it out a bit. We don't need the extra bracket stuff now. Let me take that. Yeah, you can do that now. I want to simplify it just to prove it out that it is possible. Okay, there it is. You can just bring the h into the fraction because they're being multiplied. You multiply the denominators, so then the h's do cancel. But where you have here left over is a -1. So make sure that you don't forget there's a -1 still on top. With a -1 on top, that does make it a little bit easier to make a mistake, but it's just part of a process. So let's put a -1 there and get rid of this guy. And that's it. You're done. You can now set h to 0. You can now set h to 0, so you get -1 over x bracket x plus 0, or -1 over x squared. All right, so that is the answer. So if we summarize here, if the original function is 1 over x, then the derivative, or instantaneous rate of change, is -1 over x squared. You know, it's kind of like, when I first saw this stuff, I kind of felt like an archaeologist, you know, digging around. I was fascinated with archaeology, so digging around somewhere, you know, finding stuff and then trying to piece together what the rule is, or what the big picture is of this process, or whatever you were investigating. So in this case here, we've done 3 examples and we've gotten formulas for the derivative, and each of them has been weird. Like, there's numbers that look similar, and then there's other numbers that are kind of like out of place maybe. Over here you have 1 over x, and then it becomes 1 over x squared with a negative sign. So for those that have never seen derivatives before, the rules are actually not that bad. And what we're going to do now is, for today and for next week, from this point until the end of next class, I'm going to show you a bunch of rules. I'm going to show you a bunch of shortcuts on how you can do these things, these derivatives, without first principles. So I'm going to go through several rules. And there's probably, I think, at least 5 rules that I'll cover with you. Today, though, we're just going to focus on power functions and a little bit of polynomials. So those are the big ones we'll cover today. I got lost at the 3rd line. For this specific question, Shaquille, right here. Okay, so the idea is that, so the question is, how do I get to here? What I need to have is I need to take these two fractions and I need to put them together. But the way that I can put them together for subtraction is to get a common denominator. So in this case, this is x plus h, and this is x. So the common denominator must be these two things multiplied. See, x plus h. That is the common denominator. So that means that the first one, I need to give it an x on the bottom. But whatever I do to the bottom, I have to do to the top. And for the second one, I need an x plus h on the bottom. So whatever I do to the bottom, I got to do to the top. Does that help? Okay, now that they both have the same denominator, yeah, it's funny. So in the chat there, our friend Jai's like, times like this is when I like the shortcut. Yeah, absolutely, my friend. I'm totally with you on that. I'm totally with you on that. I could tell you this, everybody. I could say, you know what? I could just teach this course and just tell you the shortcuts and say forget it. Let's not bother doing the derivations. So what we're doing right now is kind of like little proofs or derivations. And I could just do that for you, but I think that's a disservice to you. I think that it's a rite of passage. Yeah. You can definitely use the shortcut and still check with first principles, or vice versa. I agree with you, Prabiti. But anyway, from this point on until the rest of the semester, the end of the semester, we will no longer do it the long way. I will teach you a bunch of shortcuts. So let's take a look at the first shortcut, which is this one. Derivative of a power function. Derivative of a power function. There is the rule, people. This is the little rule. This little guy right here. This little guy hiding here. That is going to turn what you just saw. What you just saw that took half a page of writing for each question at least. I don't know why this stylus is not working well. What just took half a page of writing for each question, I give up on the box. It's this little formula right here. So, what does it say here? When the function is x to the power of n, the derivative, you take the n and you bring it down into the front, and then you take away 1 from the exponent. So let's take this formula here for a little test drive and see if we can make heads or tails of it with questions. Jordan, have you ever seen this stuff before? You got the right answer, dude. You got the right answer. That's correct. That is correct. Good job. And what we just did here, if I asked you to do the question the long way, it would have been a page of writing because it's x cubed. X cubed is worse than x squared. But yeah, in this case, what you do is you take the number up here, which is the 3, the power. That's why it's called the power rule. And you bring the 3 down. And then you take the exponent and you take away 1. So you get 3x squared. Anyway, what would the next one be? Let me know in the chat. What do you think the next one's going to be? That is correct, Shaquille. You take the 4 down, and then you take away 1. By the way, this step where I write -1, I don't care if you write that step. This should be just the answer. And that's cool. What do you think? Easy? Easy peasy? In the chat, let me know. If you've never seen this before, what do you think? Easy? Okay, hopefully. Let's go back in time. Let's do a rewind here. Remember this guy over here? Remember this disaster I started off today's lesson with? Remember that? Does it work with the rule that I just showed you? Does the rule work there? What's f prime? You take the 2 here, see that 2? You bring it down, and then you have x, and then you take away 1. What's 2 minus 1? Well, I mean, rhetorically, we know that. It's a 1. Oh, look at that. It's this one, see? Remember I said to you there's a shortcut? There's the astonishing face. Yes, Shaquille. Very good, my friend. Isn't that awesome? How about this one? Oh, wait a second. There's 2 things here. We'll come back to that one later. There's 2 terms there, but we'll come back to it. 35. Let's go to 35 now. You could answer every question we've done thus far using this rule. So x to the 7, what's the answer? What is the derivative? Yep, 7x, and don't forget, you got to take 7 minus 1, so 6 there. It's okay, Mohammed. Yeah, Shaquille, it does work for that one. You're ahead of the game, sir. I wonder if that's a future example. Let me just check. It is a later example, but we'll do it right now. I'll do it right now, just because you asked. So over here, the shortcut, okay? I'm doing the shortcut right now. This is not, yeah, for that you have to, yes, thank you, Prabiti. You have to turn this into a different format. So you want to write it like that. And then the derivative would be negative 1 x to the negative 2. Because you got to take away 1, right? You have to take away 1 from the exponent. And then you see it's negative 1 over x squared. And then you can write wow. Not bad, eh? So it's kind of funny that you said that, Shaquille, because when I was a student in high school and I first saw this stuff, when I saw the first principles, I was like, oh my goodness, what did I get myself into? And this is coming from someone that loves math like crazy and really did not have a situation in math where it was like, I don't like doing this. And when I saw calculus the first time and I saw this, I was like, oh my goodness, what did I get myself into? So for about 3 or 4 days of school, because it was every other day was school, I was like, what did I get myself into? But then we started doing the shortcuts, and calculus became my favorite course of all time. So anyway, it's kind of funny that happened like that. So I think we're gonna have some fun now, because these ones here are weird. I just changed the exponent here. What the heck is that? Look at x to the pi? What the heck? Any thoughts on how you would do that one? That is correct, Jai. It's meant to be Jai. It was like it's almost like it's a rhyme because when Jai rhymes with pi, so I think that's kind of cool. You were destined to answer that question. There you go. One of my best friends in university, we did our master's and PhD together, and his name is Jai too. That's why. So whenever I see you, I think of my buddy Jai. That's why. Anyway, Prabiti, pi is just a number, isn't it? Yes, it is. So that's why. So this thing here is just a number. And you don't have to write 2.14. Just leave it as pi minus 1. Don't waste your time with decimals. Same thing with here. You see the root 2? This root 2 here is just a number. So bring it down to the front. Whoops, that's a 2. And then take away 1. Just so write root 2 minus 1. All right. It's 9:50 on my clock here, I think. So let's take a break till 10 o'clock, and then we'll do a bunch more of these. I promise you guys, you've gone through the worst of it. The rest of this lesson and the next week's lesson is very mechanical and very pattern oriented. So you're gonna have a lot less stress doing it. I promise you. It's not gonna be as bad as it looks before. And for that reason, I do want to do lots of practice with you. Can we go over the harder questions again? Do you mean the limit one, Siddharth? Okay, we can definitely, what I'll do with you is this. This is what we'll do, Siddharth. We'll finish up all the ones that we have here, and then I'll make up a new one for us to do, a brand new one. Sounds like a plan? I'll make up a new one to do, yeah. The reason is I don't want to go over the same thing we just did again and again because it might, some people, half the class will be like, I already know how to do this, leave me alone. And the other half of the class will be like, more questions. So yeah, let me make up another one at the end that's comparable. And the one that was 1 over x, don't worry about that one too much. That one was just more of a challenge question than anything. So we are off to the races now in terms of mechanical. So let's see what's happening here. We have x to the negative 4. So I suspect that some of you might have worked ahead, but I'm still going to just keep a nice slow and steady pace. Our goal is to get to question 58. So about 20 questions. So let's see how that goes here. Anyway, for these easier ones, I'm not gonna ask too many questions because the feedback has been very successful so far. But for the harder ones, I'll get your interaction more, okay? So in this case, you can bring the negative 4 down. And then when you take away 1, you get negative 5. It's important that you remember that, yes, thank you, Siddharth. It's important that you remember to make your exponents positive. So the answer that I would like to see is this. Yes, thank you, Prabiti. Okay. 39. First, you want to rewrite the question. It's kind of like the example that we looked at earlier, where I think it was Shaquille that asked if we go back to that question, would it work for the weird one, the reciprocal one? And in general, yes. So we go back here and we can write this as negative 3x to the negative 4. And then we can just write it with positive exponents again. It's up to you to remember positive exponents. I'm not going to explicitly tell you this because, as you can remember, I was very strict about positive exponents up to this point, and nothing's changing. Now, question 40. Why negative 4? Because you're taking away 1. So when you do the rule, it's n minus 1, so it's minus 3 minus 1. So in this one here, there's already a 7 there. So you can do this a few different ways, but the cheapest way is like this, like to understand. That's correct, Jai. The first thing you want to do here is, if you see a number in the front, just multiply it out. So what's 3 times 7? 21. And then you take away 1 from the exponent. So there's some little rules that I'm not explicitly raising here, which this one would be the constant rule, constant multiple rule. What you're really doing here is the 7 is a constant, and what you can do is just ignore the 7 temporarily and treat it as if it was just x cubed. If it was just x cubed, you would write 3x squared. And then you can put the 7 and the 3 together through multiplication. So that's how you can deal with situations where you have a coefficient that is not a 1. Question 41 and 42 are like the two examples with the first principles with the reciprocal function. But you can still approach them the same way. So this would be like 5x to the negative 1. And this one over here would be negative 2x to the negative 1. So we can handle those separately and hopefully without too much stress. So what would happen here? Well, there's already a 5 in front. You would multiply the 1 and the 5, or the negative 1 and the 5 to get negative 5. And then you take negative 1 and you subtract 1 to get negative 2. And that works for the next question as well. But don't forget that you've got to put positive exponents in your answers. So for this one here, let's write that as negative 5, whoops, over x squared. And for the next one after that, we would multiply the negative 1 and the negative 2 to get positive 2. So that's why there's a positive 2 here. And the exponent would be negative 1 minus 1, so negative 2. Positive exponents for our answers, so let's bring that negative 2 downstairs and make it a positive 2. So what do you think? How do you feel about this? Easy peasy. Thank you, Anil. I haven't seen you up to this point today. Nice to see you, man. So let's keep on going here. The next 3 or 4, actually the next 4 questions go really, really well. They're kind of like a group package deal. So why am I keen on those? Okay, so wait a second. Can someone tell me 5x? What is the exponent there? 5x to the, what the heck is going on there? Here we have 5x. So what exponent does the x have? Yeah, it has a 1. So let's do the rule. It'd be 5, and then you would have x to the 0. What's x to the 0? It's 1, right? So this is 5 times 1. What the heck? Sorry, it's a little bit slow here. I might have to type the rest of these. It's 5 times 1. So that's 5. Okay. This one here is interesting. Okay. We're talking about derivative, which represents rate of change. It's rate of change. This number here is 10. The function is always 10. This function is constant. That's funny, guys. This function is constant. If something is constant, does it change? So the rate of change is 0. Whenever you have a constant, the rate of change is 0. Okay? So it's important for you to remember, when you have a constant, the rate of change is 0. And this one over here, if we take a look at it as well, what does that look like if I graph it? What would that look like if I graph this? What type of graph? Is it a parabola? What is it? What does that look like if I graph it? Anybody? It's linear. Thank you, Irvin. It's a straight line. And what is the slope of that line? What's the slope of this line? 5 over 1. Oh, wait a second. Isn't that the answer here? That's exactly what it's saying. It's saying the derivative, if you have a linear function, the derivative is simply the slope of that function. So let me ask you again now. What is the slope of this? Oh, it's 5. What's the slope of this? Well, it's flat. Isn't it flat? This guy's flat, right? It's constant. It looks like that. That's 10. If it's flat, then the slope is 0. Isn't that cool? Let's put them next to, let's take a look at 45. 45 is basically the two answers from 44 and 43 added together. So, what is the slope of this line? What's the slope of that line? Tell me. Anybody remember the slope of that line? Think of y equals mx plus b. Yeah, it's 5. What's the slope of this line? Thank you for BD. So, yeah, it's 2. Thank you, Jordan. It is 2. So, wait a second. What's different about these two questions compared to all the other questions that we just did? Well, these two questions have 2 terms. And how do you find the derivative of something that is more than 1 term? Well, the answer is you just find the derivative of each of the terms separately, and you add them up. So for this example here, there's 3 terms, and what you do is you find each of the derivatives of each term separately, and then just put them together. That is correct. So let's take a look piece by piece and put together the answer. So this one here is 7x squared. You bring the 2 down, and 2 times 7 is 14. And then you take, no, Mohammed, C is next, that's next semester. That's for anti-derivatives. That's antiderivative, okay? Yeah, we're doing derivative, which is the other way around. You're doing the next topic, which is like backwards derivative. Thank you, Shaquille. We'll cross that bridge when we get there. Thank you. Okay, now that takes care of this one. And these ones here, you can do them term by term, or you can do what I asked you in the previous question. Notice that this one here looks like mx plus b. See? What's the slope of this? What's the slope of negative 6x plus 3? Well, it's negative 6. That's the answer. So with these polynomial type functions, just find the derivative of each term separately. Here's a couple more for you to practice. So why don't you take a few minutes to yourself, take a few minutes, or 2 minutes if you want, and try each of those separately. I'll take up the answers in 2 minutes. All right, let's keep on going here. So this next example, we can take each of the terms' derivatives separately. So 6 times 3 is 18, and we decrease the exponent by 1 to get x squared. And this one over here is 11x, whose derivative just becomes 11. So ultimately, when you see something times x, the derivative is just the number in the front, the coefficient. For the next one here, 4 times 5 is 20. And then you decrease the exponent by 1 and you get x to the 4. This is a constant, so it's just 0. But you don't have to put 0 at all. There's no need to write the 0 down. So let's do 9 more of these. And then I'll do either, we'll see how it goes in terms of if we're near a break, or if I'll take up a longer first principles question, an extra practice question. So in this case here, we want to do each of the derivatives separately for the terms. So let's take a look at 3x to the 3. So 3 times 3 is 9. And then you decrease the exponent by 1 to get x to the 2. So we just did that one. Now let's do this one. Take the 2 and bring it down and multiply by 3 to get 6. And then take away 1 from 2 to get 1. There's no need to write the 1 there. Finally, we have x plus 1. You can think of this as the slope of the line y equals x plus 1, which is 1. Or you can treat them separately and say the derivative of that is the coefficient, which is 1, and the derivative of this is 0. But you don't have to write the 0 down. In the next question, it follows the same procedure, and I do want to emphasize the word procedure. It is predictable. So in this case here, we can bring the 10 down and multiply by the 10 that's already in front to get 100. And then the coefficient is done. Now we have to take the exponent here and subtract 1 to get a 9. And then over here, 9x cubed, we need to multiply the 9 by the 3 to get 27. And then decrease the exponent by 1 to get x squared. And then the derivative of negative 7 is just 0. We don't put a number there because it's constant. It doesn't change. In this question, we can take the reciprocal there, 2 over x, and multiply it instead of divide by writing a negative exponent. And then we can find the derivative of each of these terms separately. So the derivative of is just 3. And the derivative of that, you bring the negative 1 down and multiply by the 2 to get negative 2. and you subtract the exponent by 1. So we go like that and get x to the negative 2. This answer is mathematically correct, but presentation-wise, we'd like to see it with positive exponents. Now we're starting to get into just some weirder questions, and you might get a little bit scared about like stuff like this or like that, but don't be too alarmed, because all of these will fall back onto a power type question. So for this one, because the denominator is a single term, we can split it into two separate fractions. And then once you have split it into the separate fractions, then you can write it with exponents and finish up. So over here, this would be 2 over x, and then 1 over x squared. We still haven't found the derivative, but we need to make those exponents negative to find the derivative. So this question required a lot of setup, and that's going to be a theme with many questions, that you're going to require a lot of setup before you can find those derivatives. So now we can find the derivatives of each of those separately and have, well, bring the negative 1 down and multiply by 2 to get negative 2, and take away 1 from the exponent to get negative 2 as well. In the second term, you would bring the negative 2 down into the front. There it is, negative 2. And you would take away 1 to get negative 3. The answer should be expressed with positive exponents. So that becomes negative 2 over x squared minus, and then again, positive exponents, 2 over x cubed. Okay, how's everybody doing? How do you guys feel about this? Let me know in the chat. Thank you, Anil. Anybody else? Anybody else part of the game here? What's going on? Wow. Thank you for your feedback. I think it's important that I hear from you so that I know that we're okay, that we're working well. So just another five more questions, and then after that I'll do the first principles. Sorry, you separate the denominator. Are you talking about question 53? Yeah. So what you're doing there is, because the denominator is a single term, because the denominator is a monomial, you can split it into two separate fractions. If this bottom here was not, if it was like x squared plus something on the bottom, then you can't do it this way. And we'll talk about other rules that you could do a question like that later. Next week, I mean. So let's keep on going here. You're welcome. So here we want to do the derivative of another one that has a root as the exponent. This type of formula, you're probably never going to see it in practice, but the fact that you can still find the derivative is what's important. Because if you can do something as weird as this, then you're not going to be scared about the easier ones you'll see later. So what you want to do here is bring that root 3 down and multiply by root 3. So root 3 times root 3 is root 9. And then you would write x to the root 3 minus 1. And then the same thing with x to the pi. Bring that pi down, and then take away 1 from the exponent. This answer looks good, but I'd like you to fix the root 9. So let's fix that root 9 for a second. And that's that. That's the question. Done. The next few questions, I guess the last 4 questions, they all deal with radical or roots. So every single question that we're going to cover till the end now will deal with roots. It's important that you remember from our exponent material 3 weeks ago that when you have a root, It's actually an exponent. Can anybody remind the class in the chat what exponent goes here? This is x to the what? When you have a square root, close, Anil, close, half. It's half, right? It's all good. No, I appreciate it. Actually, I'm not going to answer 55 right away. Let's play this game for question 56 as well. What would be the exponent here? X to the what? Thank you, Siddharth. Yes, I'm glad that it's making more sense to people. So that's x to the 1/3. So let's find the derivative of 55 here. So take that half. I'm going to go through this really slow. Half. And then you'll do half minus 1. You can do that by hand or by calculator. It doesn't really matter to me. As long as you get it right, I'm happy. Try to do it in your head first, though. And you get x to the negative half, because half minus 1 is negative half. Make sure your answer has positive exponents. So that's 1 over 2, 1 over x to the half. But remember that x to the half is actually the square root of x. So the answer could be best written like this. If you prefer to write x to the half, like that, so I'll just say like this. This answer is good, but if you prefer to write it as 2x to the half, it's also good, okay? Both of these answers are acceptable. Like for the next one, because it's a cube root, the fractions get a little bit more irritating to express as a radical or a power. So for the next one here, I'm just going to write it like this style. And if it's a square root, I'll write it this style. That's kind of like my thing. Whenever the answer involves a square root, I prefer this one. And if it doesn't, I don't care, and I usually go for this one personally. Anyway, over here, let's take 1/3, and then let's do x to the 1/3 minus 1. So that's 1/3, and then x to the 1/3 minus 1. 1/3 minus 1 is negative 2/3. And the best answer, I would say, up to this point, would be to write 3, and then x to the 2/3. So there's a couple more questions, at least the ones that I have here, and then I'm going to show you. I'm going to show you a website. Yes, yeah, you can put it in root form. You can definitely put it in root form. I just said for this one here, Jai, I don't care if you do or don't. But yeah, you can put it in root form. Let me do that though, if anybody does want to see that. You're welcome. So if you do want it in root form, the answer would look like this. Cube root of x, and then there would be a 3 in front. Both the answers are good. This answer is good, this answer is good. Okay, I'm gonna give you like 5 minutes, and I want you to figure out these 5 minutes, okay? So I'm just gonna pause it for 5 minutes. All right, let's take a look at the first one here. Hopefully you made sense of it. The first thing that I would do here is I would multiply the 1 over 100 times 100. I think that's right, Jai. I think that's right. Just make sure your exponent's positive, so when you bring it downstairs, it becomes positive 99. So in this case, let me take out the extra step here. So that's 100 times 1 over 100. And then you have x to the, okay, this is a little weird. It's 1 over 100 minus 1. So as Jai correctly did here, you get these canceling, and you get a 1 in the front. So I'll leave the 1 alone. But then you have here this. What is 1 over 100 minus 1? Well, that's negative 99 over 100. The answer should be written with positive exponents. So the final answer could be that. Or you could write it as a root, which I prefer not to do for this one, if that's okay. And question 58, well, what the heck is happening here? You got x plus 1 over root x. That's a little strange. So what are we going to do there? Well, the bottom is a monomial. It's still a monomial. Yes, you can separate them. So that's x over root x, and then you have 1 over root x. Yes, I'm speaking. Can you hear me, Siddharth? Can anybody hear me in the chat here? Okay. Okay. Thanks, guys. No. Keep Siddharth. Wow. Wow, you guys are very gentle. You're very gentle. I will anyway, I'll let that go here. So we have x to the 1 and then x to the half. And then we have x to the negative a half. Sorry, let me write that separately. Let me do that in 2 steps. I'm just going to do the work on this one over here because it's a little bit of extra writing. Siddharth, can you hear me now? Okay, I'm glad. Don't worry. When the end of the semester comes and all of this trolling is over, I will remember one name, and it will be Siddharth, and he will get 100% in the course. Well, not really. I don't know. Maybe he's getting 100. I don't know. No, that's not nice. That's not nice. Everybody gets 100. How about that? Everybody gets 100. No. This is not a game show. This is math. This is serious. We have to be serious. Okay. Sorry, I just have to finish this question here before I lose my train of thought. So what I did was I wrote these as exponents. I just got 1 to the power of 0. What the heck? No. I'm not sure how you got that. I see, yes. Okay, I better get back to business here, people. This chat's making me dizzy. So anyway, let's take a half minus 1. This chat was making me dizzy for a second. You overwhelmed me. I'm working with an AMD processor then too. All right. At least someone got my joke. All right. Nothing wrong with AMD. All right. Anyway, after a long and painful journey through this question, I think this is where I quit and I say I give up on calculus for at least 5 minutes maybe. And then I feel better about it later. Anyway, can someone confirm in the chat that this is right? I think Jai has something there, but I'm just trying to read through my answer first. Someone confirm this, please. Thank you, Jai. Yeah, mine looks like yours. Okay, we're good. Anybody else have any comments about this one? I'm trying to shorten it up a little bit. Anyway, what you'll see next week on your quiz, not this week, but next week, is predominantly this kind of stuff. Yeah, you can put that in root form, Jordan. I just prefer not to because I kind of got exhausted from writing down so many exponents here. But yeah, you can definitely put that in root form. I mentioned earlier when it's a square root, I like the root better. But you know, if you're typing something up on the quiz and you're like, I don't know how to type the root properly, you can leave it as an exponent. As usual, I do go through all your answers. Yeah, I prefer that to actually a little bit too here. All good, my friend. Okay, this stylus thing is sucking the life out of me today. Okay, anyway, it's 10:38. What I want to do, was it Art that asked for reinforcement on the first principles? I think it was. I'm going to ask you, I'm going to set up a question here. And this is how, thank you, Siddharth, for getting back to me there. What I'm going to do is this, it's 10:40. I'm going to put a question up, and it's first principles. And I want you to take 5 minutes on your own and try it, see if you get the answer, and then I'm going to review the answer with you, and then we'll take a break, and you'll have your quiz after the break. Your quiz is not till 11:20, but anyway, sometime. And if we have time, we'll do 2 of them. I don't mind. I'll do 2, 3, 4, how many you want. But anyway, practice is good here. So here, find the derivative of f of x equals, let's do 4x squared minus plus 1. No, not today, Jordan. This booklet, we're doing it over 3 weeks. It's a big booklet. Yeah, the thing is that this is a very skill-based and a very steep learning curve in the beginning. And the mistake that I could make is that I just try to do the whole thing with you in a short time, and then you don't really retain anything. Yeah, ideally each section should be a lesson, but we can't really do that in this format. So anyway, here, find the derivative of that. And I'll say here, using first principles. So the first step here, I wonder if it's in the side here. No, we don't, no freebies, so I have to type it. So I'm looking for you to go through this process. And one more thing at the top here, check, verify your answer. I'll check that in a minute, Vittorio. Verify your answer by taking the derivative using the shortcuts we learned, okay? So there you go. Off on your merry way here. I'll give you guys 5 minutes, okay? 5 minutes on this one. Your final test. Let me look that up in a second here. It's in the course outline, but I don't have the course outline on this screen. I have to open it up elsewhere. December 15th. I think Max is right there. Thank you, Max. I have to open up my calendar, actually. The course outline doesn't have dates. It has week numbers. 15th. Yeah, December 15th. Thank you, Max. December 15th. You're welcome. Yeah, the answer should be 8x, but that would be the cheap way, right? Like using the shortcut. So this is like part one here, right? And then part 2 is what you were saying there. The last, yeah, the shortcut kicks butt. The last day of exams is the 15th, 16th, 18th, okay? Last day of exams is the 18th for BD, I think. You're welcome. It's a little strange this semester because the exams are the exam week is usually a little bit, it's usually earlier, but just the way the calendar works out, it's actually literally slammed up before the holidays. So anyway, it is what it is. So I just did part 2, which is the shortcut. So this verify business over here, let's put that in blue. So that's this step right here. I'll be back in a minute. Quiz is at 11:20. Yes, Jordan. I'll be back in 1 minute. Okay, as you are slowly working through it, yeah, that's the other way. I mean, in terms of writing it, in terms of writing your answer, the style. Yes, Jai. I'll mention that after I finish this question. So in this case, you're welcome. In this case, well, maybe you have it. First principles derivation, and you can see that it's pretty long. but not much more difficult than the other ones that we did. And notice that we did. I'm happy that it worked out too, Praviti. You don't see my smile, but yeah, I'm certainly happy about that too. So these are the same, and I guess that's the big thing. Today you are able now to connect what we did last time, which was instantaneous rate of change, and now you're able to connect it to the derivative and practice some of the shortcuts. And that's fantastic. I'm glad that it makes more sense now. And I'm really happy about that because this is a process, and once you master the process, the amount of steps is a little bit overwhelming in the beginning, but once you look past that, it's actually not too bad. So I don't mind doing one more with you guys. If you want, let's do one more maybe, and then we'll take a break, and then you'll have your quiz at 11:20 as per usual. So let's do one more. Let's do one more. I think it's important. I'm going to do one that's a little bit harder because these are all been x squared or 1 over x for that earlier one. Let's try a cubic. Let's try x to the 3 together. So I'm just going to copy and paste the entire slide. Actually, I'll just duplicate the slide. Before I do that though, is there anybody, let me know in the chat if you need some time to look through this still. Anybody, let me know in the chat. Do you need more time to look through this? Okay. Well, I have it on the side here. Hopefully the font is large enough. What I'll do maybe is take this one. Let's take this one here. I mean, it's big enough that I can do that now. There we go. The only reason that I shrink the font down is because it acts a little bit weird when I'm editing equations. It scrolls up and down by itself. But yeah, I think we're good. I think that looks pretty good. So let's move on here to the next example. So I'm just going to get rid of all this stuff here. And get rid of this stuff here. I'm not going to ask you to verify. I mean, verifying is easy for this one. The question is this. X cubed. I'll just put the answer first. What's the answer here? What's the derivative of x cubed? Anybody quickly? That's an easy one. What's the shortcut answer? Thank you, Praviti. 3x squared is correct. What I'm asking you to do now is to work through finding the derivative of this. Now, I'm going to work through a little bit of a little hint here. This is a helpful side algebra. If you have x plus h cubed, that equals x plus h times x plus h. No, I don't. I'm not going to give cubes for no first principles cubes. No way. That's too much for a quiz. Yeah. No. For your if I ask you first principles on a test or a quiz or whatever, I promise you it will be the worst will be as x squared. Okay. You're not going to get higher than x squared. But it would be fun. Actually, it's kind of funny because the proof, I've actually given you guys the proof in this book. Yeah, I know. Over here, see this here? This is the proof. For the power rule, that's the proof there. And it does involve not cube, but any power. So that's just crazy. Anyway. By the way, you're not responsible for any proofs for that kind of stuff, so don't worry. This one here, if you know Pascal's triangle, you can use Pascal's triangle here. And if you don't know Pascal's triangle, then you can do it the long way. Let me do it the long way first. So now you would just expand the heck out of that. And let's do that. No cheating here. Let me do it the long way here. X cubed plus 2x squared h plus xh squared plus x squared h. I hate when it does that. I'm not looking as I'm typing. I don't look at the thing there because I was typing it sideways. Okay. Anyway, where was I? 2xh squared plus h cubed. So that's from Pascal's triangle, that's 1331. That's how you know the answer. See, it's 1x cubed plus 3x squared h plus 3xh squared plus h cubed. I know how to expand binomials using Pascal's triangle, and you should as well. So that's what I was saying is you can jump to the answer here if you know Pascal's triangle. Anyway, that little thing on the side should save you a little bit of time with the question. So I'm just going to dump that thing down here at the bottom so it's out of the way. So you can use that to your advantage here. So all that work that I did on the side goes right here. That's why it's so important to know how to do your algebra and expanding binomials. So the x cubes cancel, and now you can take out an h, and you can cancel the h's out, and now you can set h to 0. So you get 3x squared plus 3x times 0 plus 0 squared. And there you have it. Wow, that was intense. If you can do this question, you can do anything, honestly. These are the worst. Cubics are just a pain. And if you go past cubics, then it just turns into a bookkeeping nuisance. Anyway, it's 11 o'clock right now, and I still owe you a break. So let's take a break, I guess, and we'll come back. And if you want, we can do another one, or we can answer any other questions that you might have. So let's resume at 11:10. For those that don't want to, that just want to write the quiz, you can take a break till 11:20. That's fine. How did I went from x plus h from here? This one here? Yeah, okay. You can just take a break till 11:20. That's fine. I'll come back at 11:10 for questions though. It's optional, I guess. Now, Siddharth, yeah. To the next line, my dear friend. It's all of this. See all of this crazy stuff here? You have to do all of that stuff, and that gets you to this. Isn't that exciting? Yeah, we just expand, but you know what I did? I did it on the side here. You see why would I want to do that on the side though? Because I don't want to write, this is 5 lines of writing, right? I don't want to write 5 more lines of this. It's just too much, right? Yeah, it saves paper, and it also saves my temper, because I have a very little patience for annoying things, and that's annoying right there. So, no, I'm very well mannered with you guys, but you know, common sense. I love common sense, so we got to use that. Anyway, I'll be. You're welcome.